Hello everyone. Today we are going to solve a problem from SuMON Fortnight 25 of level 2 program. In this program we aim to provide problems to the students of grades 5 and 6. This problem is about filling up a 3x3 grid with ones such that the sum of numbers in each row is 2 and the sum of numbers in each column is 2. We have to find the number of ways to perform this. There could be several ways and one of the ways is given. So let's try to find all possible ways and let's get started. Here is the actual question. You are given a 3x3 square grid and you are going to fill it with multiple ones and the sum of each row and column should equal 2. So we have to figure out the number of ways to perform it. And please note that at most one entry should be filled in each unit square. Let us consider the given 3x3 grid as the following image. Now, notice this. If you need the sum to be 2, there should be exactly 2 2's in each row. So that is clear. But in what configuration? This is the question that addresses or accounts for the computing permutations in them so that we can estimate the number of ways to perform this. Now, let's fill a blank in the first row by having a dash, and then the other 2 unit squares should be filled up with 1. Suppose if this is the case, and if the second row is filled the same, then you will have a trouble in the third row, because when you fill up a 1, the first column has a sum of 1. And if you fill up a dash, if you leave it empty, it will be 0. So in either case, it's not going to 2, and therefore we cannot achieve our required configuration. Therefore, you cannot have 2 identical configuration of ones in the rows. Therefore, the second row should have the empty unit square not as the same as the first row. Not the same as the first row. Therefore, the same argument carries forward for the third row once. And hence, any valid configuration will have the 3 blanks misaligned. They actually cover all 3 columns. They can never be aligned or stay in the same column. Therefore, the configurations can easily be counted by just filling these blanks into these rows, 1 in each row, such that no 2 occur in the same column. So let's figure that out. And of course, after doing that, we are just going to fill up the ones in the remaining spaces. Suppose if I fill the blank here, then I may fill up the blank here in the second row and here in the third row. This is one possible configuration, and now you can fill up the ones. Notice this will always give us the sum of 2 in each column, because there is exactly 1 blank in each column. So the other 2 unit squares are filled up with ones. So we will have our required configuration. So now, for filling up the blank in the first row, you have 3 choices. For filling up the blank in the second row, after filling it in the first row, you have only 2 choices. And after filling in the first and second row, you will have only 1 choice. Therefore, the final count is just 3 times 2, because for each possibility of the first row, there are 2 possibilities in the second row. So 3 times 2 times 1 evaluates to 6. Therefore, you will have 6 possible valid configurations in which sum of each row and each column is 2. we try to make students think in these directions, which might not be a conventional question, but that engages the student for a very long time. We have given this problem for a grade 5 and grade 6 students who have a minimal exposure to such questions. But they can solve it because they need not know any advanced concepts to tackle this. So we will meet in the next problem solving video and solve more interesting problems. Thank you everyone. Bye.